Welcome guys. Today we're going over proportional lengths. This is the last PowerPoint video, notes thing that we're doing in this chapter. As a bit of a heads up, there's going to be about 6 theorems as well as a couple other facts in this video. So be sure that you are writing down examples, labeling carefully, and writing down the important pieces of information. Let's get started. The first theorem up is the triangle proportionality theorem. This one states that if you have parallel lines in a triangle, then the pieces of that triangle are proportionate to each other. If you want to pause the video right now to go ahead and just write everything down, now would be a good time. And we're back. All right, so what this one is saying is that once you have parallel lines in a triangle, so you have a line that intersects both sides of the triangle and it is parallel to the base. That means that this piece and this piece are proportionate to this piece and this piece, which is slightly different than what we've been doing so far. So far, what we've been doing is a side is proportionate to a side. Okay, now we're doing a piece over a piece. So this would mean that you have AB over BC is proportionate to AE over ED. Now the converse states the opposite, as converses do. This one states that if you have the proportion, then you know the lines are parallel. Okay, this will help us later when we have to start solving for lengths and X gets thrown in there and we got to find the measurement of the pieces. Okay, so the first one goes from parallel lines to proportionate pieces. The converse goes from proportionate pieces to parallel lines. As a last note, make sure that you're aware that it's one side proportionate to the other side. So notice that the red ratio is all together and the blue ratio is all together. Now let's go ahead and practice. So in this first one, we are told that the lines are parallel. ST is parallel to RQ. If PT is 7.5, TQ is 3, SR is 2.5, we need to find PS. Okay, so since you have parallel lines, you can go ahead and set this up as a proportion. So I'm going to go X over 2.5 is equal to 7.5 over 3. Remember to keep everything in order. So now I'm going to cross multiply and solve. And here's your answer. Keep in mind, if you did not have parallel lines, you always could have broken this up into 2 separate triangles and solved proportions like we've been doing so far. This one, though, this method is particularly for if you have parallel lines. Now in this other problem, we've been given lengths and now we have to prove if the 2 lines are parallel. In order to do that, we need to prove that these pieces are proportionate to each other. Now we're told that EH is 3 and that FH is 9, or HF is 9. Okay? Then we're told that DG is 1/3 the length of GF. So DG is equal to 1/3 of GF. Well, if you think about it, this problem is nice because they already gave us the reduced ratio of DG and DF. Okay, DG over GF is 1/3. Okay, which means that as long as these sides simplify to the same scale factor, then they're proportionate. So let's try it. We have EH over HF, which is 3 over 9, which does simplify down to 1/3, which means that yes, these 2 lines are parallel. All right, our next 2 theorems and corollaries. As a reminder, a corollary comes after we've proven a theorem, and these are pieces that follow logically, or conclusions that follow logically. Now, the proportional parts of parallel lines states that if you have three parallel lines or multiple parallel lines, then they cut off the transversals proportionally. So all of these little pieces, AB is proportionate, AB and BC is proportionate to EF and FG. Okay, keep in mind, you're still comparing one side of the transversal to one transversal to the other. Okay, so maintain your order. The next one is the congruent parts of parallel lines. All right, so this one gives you a bit more information. It states that if you have three or more parallel lines and they cut off congruent segments on one transversal, then the other side of the transversals must also be congruent. Okay, so in this one, we're told that AB is congruent to BC. And since these lines are parallel, that means that EF is congruent to FG. Okay, please pay attention and note this. AB does not equal EF. Okay, you're not comparing the two transversals directly to each other. But since one transversal is cut into congruent segments, therefore you know the other transversal is also cut into its own congruent segments. Let's practice with these. So here we have it. We have a triangle, we have congruent segments, and we have these perpendicular angles. If you remember from way back in last semester, there was the perpendicular transversal theorem, which stated that if two lines were perpendicular to the same line, then they were also parallel. So now we know that these two lines are parallel. We can say that these two expressions are congruent. That gives us 2x plus 1 is equal to 3x minus 5. And then we solve. And here's your answer. Now there are a lot of different examples of this problem, so make sure you're paying attention for the two big things. You need parallel lines and you need congruent pieces in order for this to work. All right, the next theorem. So if you're counting, this is theorem number 5. We've got one more theorem and a few facts to go. The triangle midsegment theorem. Now, I don't know who remembers the trapezoid midsegment theorem, but that was when we had a trapezoid and the line in the middle intersected the midpoints of the two legs. Okay, and there were all sorts of theorems and properties that we got from this. But that was what a midsegment is. It is a line that intersects the sides in their midsegment, or at their midpoints. For triangles, it's the exact same thing. The midsegment of a triangle is the segment where the endpoints are the midpoints of the two sides. Okay? The theorem then states a few things. It actually states two things. If you have a true midsegment, okay, that means a line that intersects the two sides of the triangles at their midpoints, then not only is the midsegment parallel to the base, but the midsegment is also half of the base. Okay, so if FG was 12, then JK would be 6. Let's practice. Now, automatically this picture may look confusing, but the key thing to notice is that there's actually two different triangles going on here. Okay, and the way you notice this is you pay attention to the midsegments, because if these lines are midsegments, then they must be parallel to the base. So FE, okay, the side that it can only be parallel to would be AB. And then we have DE is another potential midsegment, and it can only be parallel to AC. So if you think about it like that, you can orient yourself on this picture a little easier, and it'll make the problem make a bit more sense. So first off, let's try to find DE. So I'll use blue so that we stay kind of in theme. Now, if DE is the midsegment, then that means the endpoints are going to be intersecting at the midpoint. So the first thing I have to do is check to see if D and E are respective midpoints. So here's point D. This is parallel or is congruent to this, which means yes, DE is a midpoint. Here's E, and the same thing is true. It is the midpoint of CB because both of these pieces are equal to each other. All right, now let's remember our rule. Since this is a midsegment, that means that the midsegment is half of the base. So then DE is half of 15, or 7.5. Next, let's go to DB. Now, we've already proven that E is a midpoint. That's already been proven. Now we just have to see if F is, and it is because CF and FA are both congruent to each other. Okay, therefore that means that FE is equal to half of its base of AB. Okay, now in this case we know we have FE, so 9.2 is equal to 1/2 AB. We need DB right here. So first let's solve for the whole, and then we can find the piece. If we multiply both sides by 2, we get that AB is 18.4. Next, we know that DB is half of the whole base. Because remember, D is the midpoint, therefore DB is half. So I can take 18.4 and I can divide it by 2, and that will give me DB, which ends up being 9.2. So we've already gone over 5 theorems, and that's on top of the other theorems we've already been learning. With all this information, we now know a lot about similar triangles. Let's bring it back to the basics though. Remember, at the bottom of it all, corresponding side lengths of similar polygons are proportional. Okay, this is where we have our scale factor. Never forget the scale factor. Okay. We know from other lessons that the perimeter and the area also have to be proportionate to the scale factor. But there are other things that are included in this category. Altitudes, angle bisectors, and medians all are proportionate to the scale factor, which means that all this information, including corresponding side lengths, are all proportionate to each other and to the scale factor. So as long as you can match the pieces together and the triangles are similar, then you can set them up into a proportion and solve. Here's what I mean by that. So in this first example, we have 2 altitudes. As a reminder, an altitude is a line that goes from a vertex and intersects with a right angle on the opposite side. So both of these triangles have altitudes. Now we need to see if both of these triangles are similar, which after a glance we know they are because of the angle similarity postulate. My bad. So now we can create a proportion using these measures. I have a side right here and I have a side right here. Both of these are also my numbers, so I can go ahead and find my scale factor using this information. So 8/6 divided by 2 to both sides gives me 4/3. This is my scale factor. Now I can use this to solve for x. I'm going to do one altitude, x, over the other altitude, 9. Now you cross multiply. And there's your answer for x. Now when you come to the other side, the other triangle, this example, same principle, different given information. In this first example, we were given altitudes. In this second example, we're given medians. As a reminder, a median is a line that goes from the vertex and intersects the opposite side at its midpoint, which both of these do. And because both of these triangles are similar, again through the angle-angle similarity postulate, we can go ahead and set up our proportion. So again, I'm going to do side over side first to get my scale factor. Divided by 3 both sides, that gives me 4 over 5. And I'm going to set that equal to my altitudes, or my median, sorry. X over 10. Make sure you're keeping your order consistent. Cross multiply, and we have 5x is equal to 40, x is equal to 8. Okay? As long as you know these rules, the math itself is fairly simple. Make sure you know the rules. The best way to do that is through practice and through looking at the pictures and recognizing these given pieces of information. All right, we are almost done. This is our last theorem of the video, the triangle angle bisector theorem. This one states that if you have an angle bisector, then the opposite sides, opposite pieces, are proportionate to the sides. Okay, so the way you would write this one is literally you're going to do one side of the triangle over the other side of the triangle. Okay, keep your order together. So this means I have 10 over 4 would be proportionate to 15 over x. Okay, I'm going to simplify it down just to keep in the practice of getting my scale factor. Divided by 2 gives me 5 over 2. And now I'm going to cross multiply. Okay. Now I will make a small comment right here. Remember back to that very first video, the very first notes we took. We talked about how proportions can be written in different ways, so long as when you cross multiply, it can come out to the same thing. You don't have to write it as one triangle over the other, like I demonstrated here. You could write it as top over bottom. All right, that could work too. So you have 10. Now you can't see that color and I'm staring at it. So you could write 10 over 15 is equal to 4 over x. As long as when you cross multiply, 10 multiplies to x and 15 multiplies to 4, it's still the same proportion. It still works. Okay? Whichever way you see first. If you see the blue and the red one first, go for it. If you see the green and the yellow one first, do that one. Just make sure your cross multiplication stays the same. And here we are on our last group of examples. I'm going to do number 5 for you. Then the video will pause. You can do the other 3. When it plays again, you'll see the answers and you can check and make sure you did all your work correctly. Okay, so here we go. First off, I need to check and make sure I have one of my theorems. I see an angle bisector, therefore I know this one will work, due to the triangle angle bisector theorem. However, I'm missing this length right here. I know the total is 32 and that this piece is z, therefore this piece has to be 32 minus z. Okay, you can have expressions in these problems. Now me personally, I'm actually going to do my numbers on top of each other, so 15 and 9, and then the bottoms together. Okay, that way I can get a scale factor and compare it to my variables. So I'm going to do 15 over 9 divided by 3, that gives me 5 over 3 as my scale factor. Now I'm going to set this up to my other ratio. 15 was on top, so z has to be on top because it's on the same side of the triangle as 15. So I have z over 32 minus z. When you cross multiply, you're going to get this. If you did it the other way, that's totally fine, so long as you get this cross multiplication. Then from here we solve. And here's our answer for z. As a reminder, make sure you read the questions carefully. Sometimes the problems will ask for Z, sometimes they'll ask for the segment. Just make sure you read the problem and give the question what they're asking for. All right, the video is going to pause. You guys do these other 3 examples for some practice, and when the video plays again, you'll see the answers. All right, and here are all your answers. Now I also put next to the problem the reason why we could set up the proportion. So for 12 and 20, those are both triangle, angle, bisector theorems, whereas number 8, that was a mid-segment of the similar triangles are proportionate. Okay, so depending on the information you receive, that gives you permission to set up these proportions, but you always have to check for the information first. Now for all 3 of these problems, I always found my scale factor first. I just find that helpful, especially for later problems. Plus, it just gives me smaller numbers, and I like that. But you don't have to do it that way. You don't have to find your scale factor first, as long as when you cross-multiplied, you got the same cross-multiplication that I did. If you have any questions, please star them, circle them, whatever, and either ask me in class or during office hours. But I will see you next time.